Hello once again, our most valued student. My name is Confident and welcome to our revision guide for Physical Science grade 10. And in this lesson, we're looking at electricity. We've been looking at some previous lessons on magnetism and electrostatics. If you have not covered those topics, I'll encourage you, look at the channel and watch the previous videos because they will make sense when you come to this topic. This is a very, very important topic for your grade 10. Let's dive straight into the lesson. It says draw an electric circuit that shows the following components and how they are connected. The battery with an internal resistance, a resistor, a bulb, an ammeter, a voltmeter, a switch. And then let's quickly try to sketch that. A battery, remember how a battery is like. So a battery, let me just make two. A battery consists of two or more what? Two or more cells. So this switch, let's have an open switch like that, and then let's have a resistor there. And this is just a quick recap from your grade 9. Alright, so here let's have a bulb, and you know how it looks like. If I have a bulb, there is a bulb with an X there. This switch, you can see it's an open switch. So if you can label it, this is a resistor, and then this is my bulb. Now this is a battery now, and then I need you to know the movement of current: positive, negative, positive, negative. And then how are you going to measure current? You can put an ammeter here. Current, the ammeter is connected inside the circuit in line, in series. We call it in series, in line with the circuit, you see. But if I want to measure what? The voltage, for example, in this resistor, the voltage is connected across now. See, that's how you connect a voltmeter. Even if I want to connect a voltmeter here, okay, let me put it inside here. The voltmeter here will be connected what? Across. We say you connect it across. So that's where you have a voltmeter there and you have a voltmeter there. See, it's connected across. So this is the voltmeter, including that one. Alright, and then this is the ammeter. And then ammeter, what are you measuring? You are measuring current. Current is I. Voltmeter, you are measuring a voltage, which is V. Resistance is denoted by R, and then this is the what? The switch. And here it is what? It is open. When it's closed, you'll have it with those terminals in thing closed. And then current, we call what is called conventional current. What is conventional current versus flow of electrons? Now it is accepted that current flows from positive to negative, which it has been taken actually as acceptable, but in reality electrons are the ones that are flowing. Electrons are flowing from negative. These are electrons. They flow from negative to positive. So that's how electrons move. They flow like that. This is electrons. Alright. But then we don't use that conversion. We use conventional current to say current is flowing from positive to negative. So when you close that switch, that's how current will be flowing. See that? And remember I said we use I. So that's how current will be flowing from positive all the way back to what? To negative. That's how we have current flowing like that. So that is what is called conventional current. So conventional current is from positive all the way to the negative terminal of the battery. Always remember that. So they say how the following components are connected. Now a battery has an internal resistance. If I can put here like this, you will have this battery with a small resistor, and this one also with a small resistor, because it's called small r, because the battery, when you feel the hotness, you see when you're starting using the battery, it starts getting a little bit hot Why? Because inside the battery there is some resistance to the flow of current. The chemicals that are making the battery are making it difficult for the electrons to freely flow. So that difficulty of the electrons to move inside the battery, we say the battery has an internal resistance. Now you also need to explain the following terms. EMF. What does EMF stands for? EMF stands for the electromotive force. This is like the pump of the battery. Picture like a pump. So the electromotive force is measured in volts. Number one, it is measured in volts. And then what is it? The EMF is the voltage of the battery when the switch is open. I think that's the best one to say, when the switch is open or when the battery is not working. So it's not working when the switch is open. So how do you connect it? If I say let's measure the voltage of this battery, you put it there like this, like this, like this. See where I'm putting it? This becomes the voltage of the battery. So when the switch is open, when I'm measuring, when this switch is open, what I'm measuring the EMF. But when I close the switch, the voltage is going to drop. For example, let's say this battery was 3 volts. Now the moment I close the switch, you will see a new reading. Maybe it will be 2.5 volts. So you've got two readings. Open, for open is 3 volts. For closed, this is just an example, for closed is 2.5. The question is why? Now it's because of that internal resistance I was telling you about. Now what is this closed voltage? This is the potential difference here, the potential difference. So if they say what is PD, potential difference, and then it is also measured in what? It is also measured in volts. So you need to know both of them, they are voltages. And then the question is, what is the potential difference? It is the voltage, right? It's also the voltage of the battery. You just oppose it. When the switch is what now? When switch is closed, or when the battery is now what? Is working. Don't forget that. Now they are saying, and their difference. Why is it that then you must always say EMF is greater than PD, potential difference? Because why is it greater? Because of internal resistance of the battery, right? And this internal resistance of the battery results in what? In lost volts. For example, through heat. Remember, we said it gets hot. That's what you must always remember. And then conventional current versus electron flow, we just explained that. Alright, so that is that, guys. Let's look at a few definitions here. Now, okay, they are defining now what is the electromotive force. The total amount of energy, electrical energy that a battery can supply is called its EMF. The total amount of electrical energy that a battery can supply is called its EMF. It is measured in volts. It is the voltage of the battery when it is not supplying the current, you see. Then the potential difference is the voltage of the battery when it is supplying current, also measured in volts. And B, the potential difference is smaller than the EMF due to what? Due to the internal resistance of the battery. Alright. Next thing is the current. Definition of the current. The abbreviation for current is I. What is current? Current is the rate of flow of charge. Very important definition. Remember, it is the rate of flow of charge, and what we measure it? We measure it in amperes. A for amperes, which is the same as the coulomb per second. Now there is the formula for finding current. I is equal to Q over change in time. Q, where I is the current in amps, Q is the charge in coulombs, and delta T is the time in seconds. Let's look at a few examples here for that formula. Says a total charge of 2 coulombs passes a point in a wire in 4 seconds. What is the current? Remember, I That means this one I is what? Is Q over change in T. So I here is equal to the charge. They told us 2 coulombs over in 4 seconds. See that? Then I there is equal to 2 over 4. It will be 0.5 what? Amps. Don't forget it's A. The next one, a current of 0.5 amps flows through a light bulb in 1 hour. How much charge flows through the light bulb in this time? How much charge? So the moment they talk about time, you must know the formula I is equal to Q over change in time. But they mentioned something here, 1 hour. You need to convert that 1 hour. 1 hour, you must convert. Time is always in seconds. So 1 hour is equal to 60 minutes. And then 60 minutes is equal to 60 times 60, then it will be seconds. So whenever you are converting, the simple thing when you are given 1 hour and you're converting it to seconds, because you always work with seconds, you just say equal to 1 times 60 times 60. For example, let's say I give you 3 hours. What are we going to say? To convert it to seconds, you say 3 times 60 times 60. When you multiply with the first 60, it's minutes. You multiply with the last 60, it's seconds. Alright. Any number, if it's 0.5, you put here 0.5 hours is 0.5 times 60 times 60. You see, anything, you just multiply twice by 60. So that 1 hour was that, which is our time. And this, if you multiply, you get 3,600 seconds Now the question here is, they gave us current, a current of 0.45. See that is equal to, says how much charge. So they need Q over 3,600. I think that. Now the question is, how do I find Q? Obviously, guys, I need to, you see 3,600 is at the bottom. I need to get rid of it. You multiply by 3,600 here, even on this side by 3,600, so that you get it out of the way. So therefore, that is your Q. You multiply 3,600 times 0.45. Are you seeing that? So let's do that. It's 0.45 times 3,600, and then what you get, 1,620. So it's 1,620. Q is measured in what? Coulombs. Alright, so that is what you need to remember yourself. And then lastly, to end this topic, as I said, just going through, but we'll do some actual question papers. Now, resistance, what is it? It is the opposition to the flow of current. You need to know that definition. Resistance is the opposition to the flow of current. It is measured in ohms. Now, one of the important effects of a resistor is that it converts what? Electrical energy into other forms of energy, such as heat and light. So a resistor will convert electrical energy into heat and light, like a bulb. You see, a bulb will convert electrical energy flowing through it if current is flowing through it. So a bulb is lighting, so current is flowing, so that light is light, and also the bulb is hot, is heat. A battery goes flat when all its chemical potential energy has been converted into other forms of energy. That's why you say it's flat. You need to know these factors, very important factors that affect resistance, the type of the material of the conductor, that type of material, whether they're dealing with copper, whether they're dealing with iron, whether they're dealing with zinc, any type of material will affect resistance. The length of the conductor is how long that conductor is. If you've got one wire like this and another wire like that, if this is AB and this is CD, the longer the conductor, the greater the resistance. The temperature of the conductor also affects. The hotter the conductor, the greater the resistance. And then the thickness of the conductor, the thicker the conductor, the smaller the resistance. These factors are very, very important. Very important. NP, you must know them. Then lastly, resistors in series. For example, let's look at how to calculate resistance for resistors in series. Let's say I've got a battery here, and with this battery I've got my resistors in series. So I've got that one there, see, and another one there, and another one there, This is series. Series means one after the other. Now, whenever they give you a diagram like that, always ask yourself, how do you know that they're in series? Positive, negative. Now, there is my current. See, there is my current. There is my current I. So current I will enter into, let's call this resistor 1, this resistor 2, this resistor 3. So you see, current enters in resistor 1, the same current in resistor 2, the same current in resistor 3. So if the same current, same I is entering all the resistors, we say they are in series, right? So if this was 2 ohms, this was what? 3 ohms, and this was 4 ohms. Then now, what is the total resistance? Then we use that formula for series resistors. It mustn't be difficult. What do you say? For series, RS, resistor for series, you remember it's R1 plus R2 plus R3. You add them, dot dot dot, plus that. So what we have there is 2 plus 3 plus 4. And what is 2 plus 3 plus 4? Which is this is 2 plus 3 is 5, which is 9 ohms. Are you getting that? These are resistors in series. Now, what about the next one? The next one is resistors in parallel. An example, look at this for resistors in parallel. Similar, let's say you have a diagram like this, and then for resistors in parallel, you have your resistor here. Okay, let me make it like this, and then you have another one like that. That's what it means to be in parallel, but I'll show you how to quickly test for series and for parallel. Alright, so there we have a line like this. There we have. Now, how do you test that they're in parallel? So what you do is have your current, remember, plus or minus. Current is flowing I, then current is flowing I, but here current will reach a junction, and here current will has to choose. You'd say, do you go here? So if this was R1, this is R2, and this is R3. So current is a choice. This I total, we call it I total now. So this current is a choice. This total current, it can go to R1, we call it I1. It can go to R2, we can call it current 2. It can go to I3, R3, we call it I3. So you see this division of current, whereby this is another current, this is another current, this is another current. We say these resistors are in parallel because the current is splitting because of what? Different I's, different currents. Are you with me? And there's a special formula for that. So if this was 2 ohms, like previously, this is 3 ohms, and this is 4 ohms. Now the question is, what is the total resistance? Now be careful. Be careful now in this formula. It says 1 over RP means parallel is equal to 1 over R1. Be careful now on this one. 1 over R2 plus 1 over R3. Now I want you to be careful now. Let me write this. It's 2, 3, and 4. So 1 over RP. Don't forget, always say 1 over R. 1 over R. Don't say RP now. So it's 1 over 2 plus 1 over 3 plus 1 over 4. Then equal to, now be careful again. I say NB on this formula. I'm writing it again. NB. Be careful. So what do you do after that? Look at this. Take a calculator, add 1 over 2 plus 1 over 3 and plus 1 over 4. See that? You add, get your answer. It's what? 13 over 12. It's 13 over 12. But what is 13 over 12? 13 over 12 is what? Is 1 over RP. That's not RP, please. Then to get RP, you do what is called flipping. What is it? Take this to the top, take this to the bottom. It will be RP over 1, which we can call it RP. You see? Is equal to, you do the same thing, flip this and flip this. it will be 12 over 13. That's what you just do. You just say RP, you flip the other side, and then that becomes your answer. Not 13 over 12. The answer is 12 over 13. Then you find what is 12 divided by 13. Okay, I don't know what 12 divided by 13 there, which is SD 0,923. 0,923 ohms. The resistors in parallel. Do you see that? Now you can compare these two. Look at it. When they are in series, you see series has what? Greater resistance. They were same resistors 2, 3, 4, but look, I got 9 ohms. Greater resistance. So to achieve a greater resistance, you connect them in what? In series. So if you want current to be smaller, or you want current to be difficult to flow, remember resistance is the opposition to the flow of current. So if you want this current to struggle going through so that you get smaller current, put them in series. But if you want current to be high, or you want larger current, put them in what? In parallel. Look, it's 0, those 2, 3, and 4, they become actually smaller than even one of the resistors in here. The answer you get is even smaller than all the 3 resistors. You see that? So that is what you do for here. It will give you what? Greater current. Alright, so when you do this, you get less resistance. So guys, this is what we mean when you say resistors in series and in parallel. Now join me in the next lesson, whereby we are now going to look at some revisions on how you calculate resistors. Look at this: series, parallel, and a combination of series and parallel. I'll show you how to calculate this, as well as some previous papers. I'll also give you some hints. Join me in the next lesson where I go to take you through the previous papers. And again, let me repeat this: if you are not yet a part of this family, I will encourage you, become a part of us. Become a part of the family of the 24-minute lesson, where we take you through mathematics and physical science. This will ensure you a distinction if you want one. It depends how dedicated you are. Remember, everything is in your hands. I always focus on those, I call them the underdogs, those who are struggling with their maths and science. If you're struggling, I'm here for you. This channel, I designed it with you in mind. But if you're not subscribed, unfortunately, you're going to miss out a lot of videos in between. So I'll encourage you, look at the button there, at the subscription button, that red button which says subscribe. It will help you to follow up on each and every video. Whether you're preparing for your June exams or for your November exams, those, it's a must. It's a must pass exams. So I say, get ready, subscribe. What else do you do? Share the channel to your friends. Don't be selfish. Don't sell the fish. Don't sell fish. At the same time, leave me a comment. If you want some of the other concepts or other lessons that I'm missing out, give me a shout. I also have an Instagram handle. It's called, I'm not good with that part of Insta, Confinkwazi, but I'll get the handle of it. Check me out. If you want to follow, you can follow there, or you can drop me, they call it a DM. Drop me a DM there, and then we'll take it from there. Thank you.